Hey there, welcome back to Algebra 2. Today we're going to be doing 6.10, which is solving quadratic equations and ending up with complex solutions. So we saw earlier in this unit the roots or zeros of any quadratic equation can be found using the quadratic formula. And I just want to remind you that that formula is given to you on your reference sheet for your region, so you don't have to always memorize it. Since the formula contains a square root, it's fair to investigate solutions to quadratic equations now when the quantity of b squared minus 4ac, I'm going to remind you this and this, is called the discriminant. And when it's negative, we're going to get those complex roots. All right, so up to this point, the discriminant's been positive, but now we're going to start looking at what happens when it's negative. Okay, so moving on right away to exercise 1. So use the quadratic formula to find all the solutions to the following equation. Express your answers in simplest a plus bi form. All right, so it's got to be, make sure it's simplified. You can't just have any a plus bi form. All right, and the fact that they're telling you that we have to represent the answer in complex form gives you the hint that we do need to use the quadratic formula. So if by chance it doesn't tell you, like most questions won't say use the quadratic formula, it'll just say solve this quadratic. And then when it tells you that simplest a plus bi form, we know that we're going to be getting that negative discriminant. So we're going to remind ourselves what the formula is. So x equals the opposite of b. So you might want to write the formula down first if you don't have it. But since we have it right above and it's on your answer sheet, so x equals the opposite of b, plus and minus. I always say the opposite of b, because if b is negative, it's positive. If it's positive, it's negative. It makes more sense to me than saying negative b. So the opposite of b plus and minus the square root of b squared. Remember that negative 4 squared is a positive 16, so that b squared will always be positive. B squared minus 4 times a, which is 1, times c, which is 29, all over 2 times a, which is 2 times 1. So some of the math I do kind of in my head as I'm going, because it just makes it a little simpler. Now my advice is simplify your discriminant. So 16 minus 4 times 29 is negative 100. Again, calculator, divided by 2. So this is equal to 4 plus and minus 10i. Oops, I didn't leave room for that. Divided by 2. Because remember, this just to give you a little bit here, the square root of negative 100 is the square root of 100 times the square root of negative 1. That gives us 10i. So our final answer down here is going to be 4 plus or minus 10i each divided by 2, which is equal to 2 plus and minus 5i. All right, moving on. Exercise 2. So these are not in quadratic form, which means set equal to 0. All right, so the first thing we're going to do, this looks like when we do quadratic linear algebraic solutions. So we're just going to, just like we did before, we're going to bring our linear over to match or to combine with our quadratic. So minus 7x plus 10. I'm going to do it in one step. You're welcome to do it in two. Here's my equal sign. I did that so these cancel. And I get x squared minus 12x plus 40 is equal to 0. Quadratic formula. X equals the opposite of b plus and minus the square root of b squared minus 4 times a times c all over 2 times a, which is 2. One more time, I'm going to simplify under my radical. So again, you can put this right into your calculator. 444 minus 4 times 40 is a negative 16. all over 2. Just like with the last problem we did, negative 16 is the same thing as 16 times radical negative 1, which is 4I. So this is equal to 12 plus or minus 4I divided by 2, which is equal to 12 divided by 2 plus or minus 4I divided by 2, which is equal to 6 plus or minus 2I. All right, same process here. Minus 10x minus 4, minus 10x minus 4. These cancel to 0. And I get x squared plus 6x plus 11 is equal to 0. Quadratic formula, x equals the opposite of b plus and minus the square root of b squared minus 4 times a times c all over 2a, which is equal to negative 6 plus and minus radical negative 8 all over 2, which is equal to negative, now that radical 8, this doesn't come out as nice as the last ones. So the square root of negative 8 is equal to the square root of 4, takes the perfect square out, square root of 2, square root of negative 1. So it becomes 4I, nope. Square root of 4 is not 4. Square root of 4 is 2. So here's my 2, here's my I, and I'm going to put that rad 2 behind it. So this becomes negative 6 plus and minus 2I rad 2 all over 2, which is equal to negative 3 plus or minus I rad 2. Remember, we have to do this, and then we have to do this. How are we feeling? If you need to pause at this point and take a look at it again, or maybe even rewind it, go ahead and do that. Again, I really highly suggest that you watch what I do, pause it if you need to, and then when you're all said and done, stop it and copy it all down. Or even maybe stop it and do it again and see if you match the answer that I got. All right, that's really how to take advantage of these videos. When you're ready, I'll meet you at exercise 3. All right, so consider the parabola whose equation is y equals x squared minus 6x plus 13. So algebraically, find the x-intercepts of this parabola. Express your answers in simplest a plus bi form. All right, this is a little confusing to me because if they're telling me that my roots are complex or my zeros are complex or my x-intercepts are complex, they're actually not going to hit my x-axis anywhere. So we're not gonna read into that too much. So in this case, we have x equals the opposite of b plus and minus the square root of b squared minus 4 times a times c all over 2 times a. So this is equal to 6 plus and minus 36 minus 30, 42 is negative 16. 30, 52 is, there we go, is the square root of negative 16. Just want to make sure my math is right. Divided by 2, which is equal to 6 plus or minus 4i over 2, divide each by 2, and my answer is 3 plus or minus 2i. So those are the roots of my quadratic. They are not my x-intercepts because in this case, B says using your calculator, sketch a graph of the parabola. Now, best thing to do here is to come up with a table. I'm going to put this in my calculator, xy. I'm going to put this into my calculator, and I'm going to get a table. So the first thing I usually write down when I get my table is my vertex. So let's put 2, 1, 0, and 4, 5, 6, just to get some more numbers here. So this is 5, 8, and 13. And because I know that's my vertex, I know it's going to be symmetric, 5, 8, 13. So if I have to graph this, what's it going to look like? Let's see. This is 10. I don't want that. I want black. 5. 5. This is 10. So this would be 5. This would be 15. All right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So just giving an idea of what this looks like. 3, 4. 1, 2, 3. 3, 4 would be somewhere around here. 2, 5. 2 would be 5. So something like that. 1 would be 8, so almost up to here. So there and here. And 0 would be 13. So 0 would be 13 around here. This one would be 13 around here. So remember what a sketch is. A sketch does not mean it has to be an exact, but we do a pretty good job here. The sketch is just something that will help us understand that this opens upwards. Our orientation is upward, which means our leading coefficient is positive. It also tells us that we have complex roots because it does not cross the x-axis. It has a minimum point of 3, 4. So we can get a lot from the sketch. All right, so it's never a bad thing to think about getting that done. All right, and that table, by the way, came right off my calculator. No math magic here, just right off my calculator. All right, let's move on to exercise 4. Exercise 4 says use the discriminant of each of the following quadratics to determine whether it has x-intercepts. So basically what we're saying is you don't have to come up. If you're just asking or wondering if there are complex roots here, we just need to look at the discriminant, not the entire quadratic formula. So the discriminant is simply the b squared minus 4ac, which sits underneath that radical. So if that radical is negative, we're going to have complex roots. If it's positive, we're going to have real roots. Okay, or we're going to basically have x-intercepts or not have x-intercepts. So let's go to the b, and I'm going to write it down just to remind ourselves what we have. So b squared is 9 minus 4 times a times c. So you get 9 plus 40, which is 49. So this is, yes, we are going to have x-intercepts for this one because we have a nice positive number. So the next one is going to be b squared. I'm going to write it down, minus 4ac. So 36 minus 4 times a times c. So here we get 36 minus 40. So here we get a negative 4. So this is going to be a big fat no. When you get a negative 4 underneath that radical, you are not going to have x-intercepts. So 9 minus 4 times a times c. So this time we have an a. Make sure you put it in. So this becomes 9 minus 840. So we get negative 31. So this also is going to be a big fat no. All right, so Basically, what we can talk about here is what's called the nature of the roots. And the nature of the roots can tell us whether or not we have one root. Now I'm saying roots. The Common Core usually use the word zeros these days. So let's talk about zeros. So you can have 1 0. It can tell us if there's 1 0, 2 zeros, rational zeros, irrational zeros, or imaginary zeros. All right, so the nature of the roots by looking at that discriminant can tell us a whole lot. And our last problem, exercise 5, basically says which of the following quadratic functions, when graphed, would not cross the x-axis? Now, if you're sitting at home thinking to yourself, well, this is a crazy easy question because I can simply, if I have my calculator, some of us have these calculators at home, but some of us don't. But if I had my calculator, I could put each of these into my calculator and see which one actually crosses the x-axis. But taking into account what we know about the discriminant, we can also look at that, and it doesn't take an awful lot of time to do this. So if we consider, again, that discriminant being, I'm going to write it here, b squared minus 4ac. This one is b squared minus 4 times a times c. So already I can see how this is going to be positive because I'm going to get 25 plus 8 times 3 is 24, which is 49. So this is definitely out. I get a positive number here. All right, I can do the same thing here. B squared, which is 1, plus or minus this, yeah, sorry, I'm doing the whole thing. There's b squared minus 4c. I'm sorry, b squared 1 minus 4 times a times c. So this also is going to be positive because this becomes 1 plus 24. So this is also going to be positive. Taking a look at number 3, b squared minus 4 times a times c. Okay, this one's might give me trouble. So this becomes 4 minus, and 16 times 5 is 80. So I know this is now going to give me a negative 64. When you have a negative underneath, there's my answer. I like to be complete and try them all. So I would probably continue on and do number 4 and say b squared, which is 169 minus 4 times a times c. So 12 times 4 is 48, so I get 169 minus 48. Actually, you don't even have to do the math. You just have to know this is going to be positive, so I know that's not my answer. Because I just want to make sure that what I'm picking is the right one, not because I made a mathematical mistake somewhere or an arithmetic mistake somewhere. Okay? So, not horrible. We're not going to spend a lot of time talking about the nature of the roots in this class, but I do want you to understand how you can determine a little bit about the nature of the roots by looking at that discriminant. All right, so until next class, always make good choices and get your homework done and continue to be as great as you are. Bye.